This presentation contains future-looking statements and is protected by Safe Harbor. Hello from the Greenplum Summit in New York City, March 2019, as part of the Postgres Conf. #Scale Matters. My name is Ivan Novick at Novick Greenplum. This is March 2019, and I will present the present and future of Greenplum Database, a massively parallel Postgres database. Starting with Greenplum Database version 5 in 2017, Greenplum Database is a mission-critical analytical database platform. As quoted by Gartner in the Magic Quadrant of 2019, Pivotal Greenplum is often used in mission-critical use cases where downtime is not well tolerated. Greenplum version 5 is a well-rounded product with a proven feature set. It's used in mission-critical use cases around the world: government, financial, telecom, and other industries. Using our Orca optimizer, Greenplum Database can respond to millions of possible queries with the ideal query plan. Using resource groups and PG Bouncer, concurrency levels of over several hundred concurrent users can be running parallel queries in the database at high performance and with isolated workload management. The Apache Madlib library provides in-database analytics when combined with Python, R, Perl, Java, and GPText. There's a full suite of analytical libraries to be run in the database. PXF provides for an external data federation ecosystem for querying data sets that are not stored locally, separating compute and storage, and then integrating with popular open source libraries like open source projects such as Apache Kafka and Apache Spark. Greenplum can be part of your big data ecosystem. Pivotal Greenplum Command Center version 4 provides the single pane of glass you need to manage your Greenplum database system. And with new and updated backup and migration tooling, you can easily back up and restore and move data where it needs to be. And now, at today's event, we have released the beta version of Greenplum version 6, codenamed Massive Postgres Power, with the acronym MPP, which is also known as Massively Parallel Processing. As Gartner's also said in the Magic Quadrant for 2019, customers frequently called out the open source alignment with Postgres as a strong and cost-effective positive for Pivotal Greenplum. So, let's imagine the Postgres database is extremely popular and powerful, but what if the Greenplum database was a superset and could do everything Postgres could do, but also at scale and for analytical processing? So with Greenplum version 6, we've now merged Postgres version 9.4 into the database, and we leveraged the write-ahead log replication for high availability. The database now supports row-level locking for updates and deletes, and can support foreign data access with Foreign Data Wrapper API, which opens up the Postgres ecosystem of external data. The PG extensions that come with Postgres, because Postgres is a very extensible database technology, are now more easily compatible with Greenplum at scale. For example, PG Audit is an interesting extension for security analysis and auditing, which can be included into Greenplum as part of the Greenplum v6 platform. And recursive common table expressions are now available in Greenplum v6. You can combine semi-structured data and unstructured data into the Greenplum database at scale with JSON data, the JSON binary type, full text search, and inverted indexes with the GIN index. With Greenplum version 6, OLTP transaction performance is radically improved, up to 50 times performance gains on PG Bench in early testing. Greenplum's always been an ACID database. We've always had transaction semantics. But now, with optimizations, we can see performance gains in OLTP workloads. Frequently, I'm asked, does this make Greenplum into an OLTP target system? And the answer is no. Greenplum is an analytical database built for data warehousing and analytical data platforms. However, in the real world, analytical databases also need to perform OLTP operations for utility purposes, and that's why Greenplum version 6 now allows for mixed workload that combines transactions and analytics in a practical and real world use cases for large-scale analytical processing. Starting with expansion. Looking back to the previous versions of Greenplum, you can see here a sample case where we have call detail records distributed by the call ID. In this case, you've got 3 segment servers, 3 nodes, and the data rows are distributed based on the hash of the call ID into 3 machines. In order to expand to 4 machines, we now hash again and use the modulo operator based on the number of nodes in the system to determine the correct location for each row of data. When changing the size of the cluster, that implies a reshuffle of the data, and you can see the data is moved. For example, here call ID number 5 is moved over here, and number 8 is moved over here. That's to create an even balance of data distribution with the new cluster size. Moving to Greenplum v6 and using jump consistent hash algorithm. Now for the same example, when doing expansion, we do it with more minimal data shuffling. So you can see here, call ID 10 has moved, 11 has moved, and 12 has moved. That's because this jump consistent hash algorithm optimizes for minimal data movement as opposed to the more naive approach of modulo hashing of modulo, using modulo to do on top of hashing. What this implies is that with Greenplum v6, it's much easier and faster to expand the size of your cluster, and that's important with virtual infrastructure where it's easier to provision and to take advantage of these new systems with a faster online expansion process. Greenplum v6 comes with a new feature called replicated tables. In a replicated table, you create it with the syntax as shown here. Create table, name of the table, columns, and then distributed by clause, and in this case it's distributed by replicated. What this means is that all rows live on every segment of the database. So you can see here a typical fact and dimension schema. In this case, you have many calls and fewer callers. The callers will be stored as a replicated table, and all callers will be stored on every segment. The calls, which are a fact table, will be distributed so that they can be spread across the entire cluster. They're too big to store on every segment. However, when doing a join, that allows for local join processing and faster query execution. Greenplum v6 has improvements in the Orca optimizer. One of the new capabilities is called Eager-Agg optimization in Greenplum version 6. So you can see here in this sample query that we're doing an aggregation and we're doing a join. So when doing join aggregates, there are additional optimizations that Greenplum 6 can do. The speed result here is shown in sample testing of this data set and for this query. We've gone from 63 seconds to 7 seconds, or 9 times improvement. Your mileage may vary. How does it work? Well, in Greenplum v5, the grouping is done here at the end after the joining. In Greenplum v6, we push down a portion of that grouping before the join to reduce the data set and to make the join process on less data. These kinds of pushdowns are traditionally done to lower the data sizes in the query processing and to make them orders of magnitude faster. This particular technique of join aggregation optimization was referenced in VLDB under the paper Eager Aggregation and Lazy Aggregation. This is now part of Greenplum as of Greenplum v6. In Greenplum v6, there's a new option for compression. It's called zStd compression. zStd is an open source library. It was originated at Facebook. It uses less CPU cycles to achieve the same or better compression. You can see here syntax for creating a table with zStd. Create table, the name of the table, the name of the columns, and then the storage parameters. This will be a append-only table with an orientation of columnar and compressed with zStd. You can see here a comparison of zStd compression to other compression algorithms such as LZMA and zlib. And you can see here that as the compression speed increases, the compression ratio is also increasing. What this implies essentially is that you can compress the same data with less CPU and in faster time. Decompression speed is also improved with zStd. So people with large data sets that need to compress them to save space should leverage zStd compression in Greenplum version 6 and later. With Greenplum version 6, we've also made generally available through Pivotal the Kubernetes distribution of Greenplum, called Greenplum for Kubernetes. Now, why would you want to use Kubernetes to containerize your big data database? Well, you can see here that every Postgres or Greenplum database segment of a large Greenplum cluster can be run from one container. So Greenplum is an MPP database consisting of many Postgres Greenplum database segments, all connected over a high-speed network. They can all be containerized, run in Docker containers, and then communicate over a high-speed network and allow for a fully automated deployment and management of Greenplum using the Kubernetes operator, which can also manage situations such as node failures and replacement of virtual infrastructure. Moving forward to the roadmap for Greenplum Database v7, codenamed Beyond the Cluster. As one of our customers from the United States government mentioned in 2018, if we can achieve beyond the cluster features in Greenplum, we will put Oracle at a run for their money. And we now have all of this infrastructure that was released as part of Greenplum version 6, such as write-ahead logging. So we want to leverage this to operate at a multi-cluster level. So Greenplum version 7 is targeted to be based on Postgres 9.6. And the plan is to incorporate multi-segment transaction log coordination. So what that means is that if you have a system and it had many Postgres segments creating one Greenplum, and you had a snapshot of them on disk, that they can be restored to the same point in time. This kind of coordination has the potential for us to build many features beyond the cluster. Things that are under consideration are snapshot-based backup, streaming replication from cluster A to cluster B, logged shipping, where transaction logs are shipped to another server to achieve incremental updates to a second mirror cluster. Greenplum as a source for Kafka, so updates can be published through Kafka and then applied on a secondary system, whether it be Greenplum or another system. Integration with third-party change data capture tools. And then finally, slightly unrelated to this, but with the same goal of beyond the cluster, is Greenplum to Greenplum intra-cluster queries. Intra-cluster queries means that you can point at tables in a second Greenplum cluster and use them to join and share data. So you can think you have 4 clusters, each are 50 servers, but they can all query and access data in each other, creating an uber large cluster. In addition to beyond the cluster, the secondary theme for Greenplum version 7 is to achieve thought leadership for in-database artificial intelligence. So, as quoted here, with the Apache Madlib analytics libraries, Pivotal Greenplum has capable in-database analytics that allow for predictive modeling and machine learning to be applied to relational data. And what we really see here is that we have the opportunity to use the MPP database platform and to use open source libraries and to use GPU processing to bring deep learning, parallel deep learning, to the Greenplum environment. And what you're really doing is simplifying access to all of these different analytical libraries and techniques through one unified and integrated system. So by combining deep learning, machine learning, model preparation, model versioning, text analytics, text search, geospatial analytics, and then Python, R languages, we really are creating a platform for modern artificial intelligence using the very succinct delivery of a database. All the data in the database with all the libraries and analytical functions needed to process the data. So with that, Greenplum Database is going to soar to new heights, and I invite and encourage everybody to jump on board, to take advantage of Greenplum and its capabilities. And with that, scale matters.